Okay, want to finish up section 1 here about Jupiter. Couldn't quite fit it into one lecture. Let's talk about the inside of Jupiter. Now, very, very recently, we've had more information than ever thanks to the Juno spacecraft. One thing we know is that Jupiter actually gives off more energy than it receives. You might think, oh, maybe it's kind of like a star and it has fusion. But no, there's no way. It's just not nearly massive enough to be a star. Now, in this case, we have a pretty simple explanation, actually, is that there's still just heat left over. I always joke with my classes kind of that thermodynamics, I refer to coffee. And the bigger the cup of coffee, the longer it's going to hang on to its heat. And in this case, you have a really big cup of coffee. And so we think the original heat from when Jupiter formed is still there. And it's just still warm from when it formed, essentially. So we don't think there's any mystery to this one. Okay, and remember, it's not really receiving much heat. It's pretty far from the sun, so it's not giving off that much heat. It's just still giving off more than it receives, which we need to explain. So how about inside of mighty Jupiter? Well, what you see is actually not going down all that far. When we see those stripes and belts and all of those sort of surface things are really not that deep into Jupiter. So it's a very, very thin layer compared to the size of the planet. So those cloud layers are what gets all the attention. That's what we're seeing. But just keep in mind, it's very, very thin. Before you go down very far into Jupiter, something happens. You get enough pressure that the hydrogen and helium, I suppose, become liquid. Okay, the hydrogen becomes a liquid. That's important to understand. Most of Jupiter, I like to call Jupiter, we call them the gas giants, but Jupiter especially is the liquid planet. The liquid planet. Of course, we use liquid hydrogen here on Earth. That's what powered the space shuttle, for example. Liquid hydrogen, liquid oxygen. So here in nature, it becomes a liquid. So most of Jupiter is really just an ocean of liquid hydrogen. And then something very interesting happens. Even deeper down, it gets to the point where the pressure is so great that hydrogen starts taking on properties of a metal. Specifically, it's able to conduct electricity. Now, first of all, that's pretty neat. I mean, you look at a periodic table, and where is hydrogen located? It's at the upper left. It's in the column there in the group with the metals. And we never think about it that way, but that's why it's over there. It can take on those properties, but just at like extreme conditions. Well, here we have an extreme condition deep inside of Jupiter that makes it metallic, and why that's so important is that helps power the magnetic field of Jupiter, which is just off the chart. And that's a lot of it, is that so much of that liquid metallic layer is able to generate the magnetic field as it moves around. And then deep down inside, I have to be careful here. I call it a rocky core. It's made of materials like silicates and so forth that would normally be kind of rock, but they don't think it's necessarily a solid. So let me be clear about that. It's made of material that would normally be kind of rocky, but they don't think that necessarily. Obviously, we don't really know. I mean, we can't send a probe down there and find out for sure. So there's a little bit of speculation. Now, the core is 10 times heavier than planet Earth. You think, wow, that's extreme. That's a huge core. Well, it's all relative, isn't it? I mean, yes, it's huge compared to the Earth. But remember, Jupiter itself weighs 318 times the amount of the Earth. So 10, that's a pretty small part of Jupiter. Take a look, that little acorn here in the middle, that's the core. So it's a really small core compared to the size of the planet. Let's just go from the outside in. Let me go back a second. We have the gaseous layer, which is very thin. Then we have a giant ocean of liquid hydrogen and helium, and then that kind of whitish layer there around the acorn, that's the metallic hydrogen, let's call it. And then you have the core. But that metallic hydrogen's enough there to really bump up the magnetic field to incredible strengths. And it's so strong that it's actually trapped a sea of particles around it called a magnetosphere. So when you have a strong magnetic field, you're going to have a magnetosphere around your planet, which is trapping a bunch of electrons and protons and charged particles like that. It's 20,000 times stronger than our magnetic field. It's amazing. That is enough to give off radio signals. Jupiter gives off radio. My classes may do that someday. Someday I want to invest in a program called Radio Jove, where you can actually try to listen in on Jupiter as it accelerates these particles. This magnetosphere is just a tremendous area of our solar system. If you think of it as an entity unto itself, it's maybe the largest thing in the solar system. It stretches 1 billion miles all the way to the planet Saturn. It's just an incredible region that's dominated by Jupiter's magnetic field. That's not really good for us in terms of sending any humans to one of its moons or something. That's dangerous, but because it's accelerating those particles. But anyway, it's a huge, vast area. Now, what causes this magnetic field to be so strong? Well, two things. You have this liquid metallic hydrogen, and you have a fast rotation. That's it. That's what can produce a super strong magnetic field. Of course, here on Earth, we have a magnetic field, and it's strong enough that actually the particles, when they're accelerated, they give off light. We have a name for that. We call them the northern lights and the southern lights. So as you can imagine, Jupiter also has aurorae, huge, powerful northern and southern lights. So no surprise there. With such a strong magnetic field, you're going to have these strong aurorae as well. I mentioned the Juno spacecraft there, which has been doing great work here in finding more out about this very intriguing planet. So here's what the magnetosphere looks like. Now the solar wind is coming here and pushing it out in that direction. That's why we say in the notes it's teardrop shaped, because of the effect of the solar wind pushing out on it, and so it's not symmetrical. And then some of these little moons, like that little moon there, is Io, and it's right in the heart of that magnetosphere. And we'll talk more about that when we talk about the little moon Io later on. That has interesting interaction between the two things, the moon and the magnetic field of Jupiter. They have an interesting interplay there. Here you can see, I don't know if that's invisible light or not. Obviously this one's not. That's an infrared or something, or ultraviolet. But here you have, you can see the northern and southern lights of Jupiter. Just pretty amazing. Just pretty neat stuff. If you think that looks odd, seeing it as a circle, well, you know, you see plenty of pictures of Earth's northern lights from the ground. But you rarely see it like this from space, where you can see, if you look at the right here, look at that. There are the southern lights surrounding Antarctica. Amazing. And here it is from the space station. How cool is that? That's just amazing. I love the space station shots as it orbits the Earth, and you see lightning storms, and you can see the aurorae. What an incredible planet we live on. But one of our incredible things, the northern and southern lights are also on... can also be seen on Jupiter. So pretty awesome stuff. And that's all from particles actually coming from our sun that are accelerated by our magnetic field. So I don't want to forget to say that a lot of that are the charged particles are coming from the sun, accelerated by our magnetic field, and produce the light. And same thing happens with Jupiter, and looking ahead, same thing's going to happen with Saturn as well. So anyway, that's the end of section 1 on Jupiter. The next section we'll talk about its amazing moons. Thanks for listening.